Hello future A student, and welcome to this channel. My name is Omotola Fayomi, and in these few minutes we are looking at JAMB Chemistry power session. Today we are mastering gas laws, Boyle's, Charles, the ideal gas law, and Grammar's law of diffusion. These topics appear in JAMB Chemistry, even physics, year after year. Master them today and you are collecting guaranteed marks in 2 subjects. Whether you have been struggling with pressure volume calculations or confused by square roots in Graham's law, by the end of this video, you will be solving every gas law question with confidence. Within these few minutes, total coverage, let's go. Your A grade is just one video away. Before we look into the laws, let's understand why gases behave as they do. The kinetic molecular theory, KMT, gives us the foundation. Gas molecules are in constant random motion. They fly in straight lines until they hit something. They have negligible volume compared to their container. The gas is mostly empty space. Collisions between molecules are perfectly elastic. No kinetic energy is lost, and here is the key. The average kinetic energy of gas molecules is directly proportional to the absolute temperature. That is temperature in Kelvin, not Celsius. These are the 4 assumptions of an ideal gas. Real gases deviate from this behavior at a very high pressure and very low temperature when molecules get close enough that intermolecular forces start to matter. But for JAMB calculations, we treat gases as ideal. That is all you need. Now to Boyle's law, one of the most tested gas laws in JAMB. The statement, at constant temperature, the pressure of a gas is inversely proportional to its volume. If you compress a volume, reduce its volume, the pressure increases. If you expand it, the pressure drops. The mathematical relationship is simply P1V1 equals P2V2. The graph of P against V gives a hyperbola, a curve that goes downward. You can also plot P against 1 over V. That gives you a straight line through the origin. Both graphs appear in JAMB. Let me work this example. A gas of 200 kilopascal occupies 3 cubic decimeters. Find the volume when pressure is 300 kilopascal, temperature constant. P1V1 equals P2V2. 200 times 3 equals 300 times V2. So V2 equals 600 divided by 300. That is 2 dm cubed. As pressure went up from 200 to 300, volume went down from 3 to 2. Perfectly inverse. Unit note, your pressure units for P1 and P2 must match. Same for volume units. Mix them up and your answer is completely wrong. Now let's look at Charles' law, the second pillar of gas laws. The statement, at constant pressure, the volume of a gas is directly proportional to its absolute temperature. Heat a gas, it expands. Cool it, contracts. The formula V1 over T1 equals V2 over T2. The graph of volume against temperature is a straight line that, when extrapolated backward, passes through absolute zero, minus 273 degrees Celsius or 0 Kelvin. This is the theoretical temperature at which all molecular motion stops. Now here is the number 1 JAMB trap in this entire topic. Are you ready? You must always, I mean always, convert temperatures from Celsius to Kelvin before using this formula. Never use Celsius in gas law calculation. This conversion is simple. T in Kelvin equals T in Celsius plus 273. Then, for example, 27 degrees Celsius is 300 Kelvin. That is 127 degrees Celsius. That is 400 Kelvin. Let me prove it with the example. Volume is 2 liters at 27 degrees. Find volume at 127 degrees. T1 is 300 Kelvin. T2 is 400 Kelvin. V2 equals 2 times 400 over 300, which gives 2.67 liters. The temperature increased by a third, so the volume increased by a third, direct proportion. And the WAEC law, at constant volume, pressure is directly proportional to absolute temperature. In this case, P1 over T1 equals P2 over T2. Each gas in a sealed container, pressure rises. Cool it, pressure drops. Always in Kelvin. Now here is a beautiful JAMB gift. Gay-Lussac also discovered the law of combining volume. At the same temperature and pressure, volumes of reacting gases are in the same whole number ratios, exactly the same as the mole ratio in a balanced equation. Nitrogen plus 3 hydrogen gives 2 ammonia, that is 1 volume to 3 volumes to 2 volumes. So if you start with 10 liters of nitrogen, you need 30 liters of hydrogen to produce 20 liters of ammonia. The volume are the stoichiometric coefficients. Second example is that 2H2 plus O2 gives 2H2O. Ratio is 2 to 1 to 2. If 40 cm cube of hydrogen gas reacts, you need 20 cm cube of oxygen gas and produce 40 cm cube of water vapor. These questions are quick marks in JAMB. Use the coefficients directly as volumes. What happens when both pressure and temperature change simultaneously? That is where the combined gas law comes in. It is simply P1V1 divided by T1 equals P2V2 divided by T2. Beautiful, because this single equation contains all 3 previous laws inside it. Cover up the temperature terms, you get Boyle's law. Cover up the pressure terms, you get JAMB's law. Cover up the volume terms, you get Gay-Lussac law. The combined law is the parent of all the 3. Let me work the example. P1 equals 100 kilopascal, V1 equals 4 liters, T1 equals 300 Kelvin. Find V2 when P2 equals 200 kilopascal and T2 equals 400 Kelvin. Rearrange. V2 equals P1 V1 T2 over T1 P2. When you substitute 100 times 4 times 400 divided by 300 times 200, that is 160,000 divided by 60,000, which gives 2.67 liters. Write down the first step method I'm showing you. List what you know, convert to Kelvin, plug in, solve. Apply this method to every gas calculation in JAMB. You will get them all right. Now we have the master equation of gas law. PV equals nRT. This is the ideal gas law, and it introduces moles into the equation for the first time. P times V equals N times R times T. P is the pressure in pascals, V is the volume in centimeter cube, N is the number of moles, R is the universal gas constant 8.314 joules per mole Kelvin in SI unit, or 0.0821 liter atmosphere per mole Kelvin if you use liters and atmospheres, and T is always in Kelvin. The equation is incredibly powerful. It connects mass, pressure, volume, and temperature all in one formula. You can rearrange to find N, the mole, by dividing PV by RT. For moles, you get mass. You can find molar mass of an unknown gas from density and this equation. Let me calculate. Find the volume of 2 moles of gas at 27 degrees Celsius and 100 kilopascal. Convert T equals 300 Kelvin. P equals 100,000 pascal. V equals nRT over P. 2 times 8.314 times 300 divided by 100,000. That gives approximately 49.9 liters. And here is a beautiful consistency check. At standard temperature and pressure, 273 Kelvin and 101,325 pascal, 1 mole of an ideal or any ideal gas occupies exactly 22.4 liters. Use PV equals nRT to verify that yourself. Now, Graham's law of diffusion, and this one catches so many students because of the square root. Thomas Graham discovered that at constant temperature and pressure, the rate of diffusion of a gas is inversely proportional to the square root of its molar mass. Lighter molecules move faster, heavier molecules move slower. The formula rate 1 over rate 2 equals the square root of m2 over m1. Notice, for rate, you put the heavier mass on top. Let me prove it with hydrogen versus oxygen. The molar mass of hydrogen gas is 2. The molar mass of oxygen is 32. Rate of hydrogen over rate of oxygen equals the square root of 32 over 2. That is the square root of 16, which equals 4. Hydrogen diffuses 4 times faster than oxygen. Makes sense. Hydrogen is 16 times lighter in molar mass, so its rate advantage is the square root of 16, which is 4. Now, JAMB love asking about time instead of rate. More time means lower diffusion. The time formula T1 over T2 equals the square root of M1 over M2. Now the lighter mass goes on top. If oxygen takes 16 seconds, hydrogen takes 16 times square root of 2 over 32. That is 16 times 1/4, giving 4 seconds. Check. 4 times as fast means takes 1/4 the time. 16 divided by 4 equals 4 seconds. Perfect. Dalton's law of partial pressure in a mixture of gases, the total pressure equals the sum of the partial pressures of each component gas. It's simply pressure total equals P1 plus P2 plus P3 and so on. Each gas acts independently as if the other gas weren't there. The example is that if nitrogen contributes 60 kilopascal, oxygen 20 kilopascal, and carbon dioxide 10 kilopascal, the total pressure is 90 kilopascal. Simple addition. Now, gas density, the molar mass of a gas from its density. Mass equals D times R times T over P. But JAMB most commonly tests this through vapor density. The density of a gas relative to hydrogen. The relationship is elegantly simple. Molar mass equals 2 times the vapor density. M equals 2 times Vd. Carbon dioxide molar mass 44. The vapor density 22. Ammonia molar mass 17. Vapor density 8.5. If JAMB gives you a vapor density of 16, the molar mass is 32, which could be oxygen or sulfur. This shortcut M equals 2 times Vd appears in JAMB multiple times per year. Write it down, memorize it, use it. Now let me give you the 4-step strategy that handles every gas law question in JAMB, whether it's Boyle's, Charles, combined, ideal, or Graham's. Step 1 is that read the question and identify what is constant. Is temperature constant? Then it's Boyle's law. Is pressure constant? Then it's Charles' law. Is volume constant? Gay-Lussac. Are all three changing? Combined gas law. Does the equation mention moles or mass? Ideal gas law. Does it ask about rates or diffusion? That's Graham's law. Another step is step 2, convert all temperature to Kelvin before you write down a single number. This is non-negotiable. Third step is that write out the appropriate formula and identify your knowns and the unknowns. Step 4, substitute and solve, making sure all units are consistent. Here is the pro tip that experienced students use. At the top of your working, write out the law selector table as a quick reference. It takes 30 seconds and could save you from choosing the wrong formula under exam pressure. Use it, swear by it, it works. Now stop. It's JAMB practice time. A gas occupies 500 cm3 at 100 kilopascal. The pressure is increased to 250 kilopascal. Temperature stays constant. What is the mean volume? 4 options on your screen. Write your answer in the comment section. The answer is D. 2 cm3. Here is the working. Temperature is constant, so we use Boyle's law. P1 V1 equals P2 V2. P1 is 100, V1 is 500, P2 is 250. So 100 times 500 equals 250 times V2. That gives 50,000 equals 250 times V2. V2 equals 50,000 divided by 250, which is 200 cm3. Let's sense check. Pressure increased from 100 to 250. That's 2.5 times bigger. Volume should be 2.5 times smaller. 500 divided by 2.5 equals 200. Same answer. If you got that right, you are owning Boyle's law. If not, you now know exactly how to approach it. The pattern is always identify constant variable, choose law, plug in, then solve. Now, second practice question, and this is Graham's law. Gas X has molar mass 4. Gas Y has molar mass 64. How many times faster does X diffuse compared to Y? Place your answer in the comment section right now. The answer is C, 4 times faster. Formula is this: rate of X over rate of Y equals the square root of my over mx. Put the heavier mass on top for rate. Square root of 64 over 4 equals square root of 6 equals 4. Gas X, they are 54 times faster than gas Y. Gas X with molar mass 4 is helium. Gas Y with molar mass 64 could be sulfur vapor. The lighter helium moves 4 times faster than heavier sulfur, exactly as predicted by Graham's law. Let me highlight the JAMB trap. Many students choose B, 16, because 64 divided by 4 equals 16, but they forgot the square root. Always apply the square root at the end. Square root of 16 equals 4, not 16. This mistake costs marks every year. Do not let it cost yours. And here it is, your complete gas laws cheat sheet. 8 laws, all formulas, all conditions, all key facts in one table on one slide. Screenshot this right now. Every gas law formula you will ever need for JAMB. Boyle's, Charles, Gay-Lussac combined, ideal, Graham's, Dalton's, and vapor density, and the 3 rules that govern them all. Rule 1: always convert Celsius to Kelvin by adding 273, no exception ever. Rule 2 is that identify what is constant to choose the right law. Rule 3: keep all units consistent throughout. Follow these 3 rules and you will get every gas law question correctly. Share this cheat sheet with your study group, post it in your WhatsApp class group, print it and stick it where you study. This table has everything. Yes, you did that in few minutes and you have completely revised gas law. Boyle's law, Charles law, Gay-Lussac law, the combined gas law, the ideal gas law, PV equals nRT, Graham's law of diffusion, Dalton's law of partial pressures, and vapor density. That is 8 gas laws in few minutes. You are not just studying, you are building an A-grade chemistry brain. One video at a time. Now, here is what I need you to do. Like this video right now. One tap. Massive impact for other students finding this content. Subscribe and turn on the notifications so you never miss another JAMB Blitz. Share with your study group if you benefited. Your classmate will too. And comment below, what is your JAMB chemistry target score? Is it 270, 300, 320? Mention it in the comment section. I will read it and stay tuned. Next up will be another exciting topic. Every gas law you must master is another guaranteed mark in your JAMB pocket. Your A grade is not a maybe, it is inevitable if you keep putting in this work. I'll see you in the next one. Keep going. More cares.